you must know to interpret these charts, all right? Now, this is not difficult. You're going to get the booklet, so you will have the, what we call the wave numbers, right? But without, even without, even without the booklet, let me see if I have the, all right. This is what you're going to do. We'll be able to identify alcohol, carboxylic acid, ester, and the carbonyl group. C is concentration. All right, yeah, so back to this. You should be able to identify alcohol, carboxylic acid, ester, and the carbonyl group. Using these numbers, right? When you get, if you get a chart and you want to interpret it, for the left-hand side of the chart, that is what will help you to determine if you have carboxylic acid or an alcohol. When you get up to this end, right, in the region of the 3,000 mark, if you see a peak, it should be of a reasonable width. So something of about this size, that indicates the OH group. All right. Now look at the width of this. It is very narrow. So it's not OH. All right. Those are CH or CC bonds. All right. So round about 3,000, you see a narrow peak that is not OOH, that is not a carboxylic acid either. All right. If you see a peak like this, that is kind of broad, that's an OH in a regular alcohol. All right. If you see a peak that is broad, something like, all right, if you see something like this, up at the 3,000 mark, that's the OH group, the OH in a carboxylic acid. Without even using the specific number. Once you get a graph and you see a very wide peak at the left-hand side, that's OH, but OH for a carboxylic. As you see this, you know it's a carboxylic acid. Now, if you do not see it, it's not a carboxylic acid. So this one is not a carboxylic acid, it's not an alcohol, because you don't get those peaks. This narrow peak, that's carbon to carbon and CH bonds. No OH is there. Scroll down a little. No OH. We don't have any OH. This one, as you can see now, this is your OH peak. All right. I wanted one with an acid. It's not there. I will post one with a carboxylic acid in the morning. All right. So the question now, it says, all right. So I told you, you should be able to identify alcohol, carboxylic acid, ester. For the ester, C double bond O, single bond O, C, right? That's the ester. So for the ester, you should have a peak. When we say peak, right, it must come very far down. So this is a peak, this is a peak. These ones, they are not far down, so we don't use them. All right. Use the ones that are coming very far down. As I said, this one, we don't really need to use it because we already know that alcohol is not there, carboxylic acid is not there. This is too narrow. All right. The C double bond O, that will come somewhere like about 1600. And if you check 2000, 1900, 1800, 1700, if you see a narrow peak anywhere in the 15 to 1700 region, that is C double bond O. So your compound is in this group. All right. Three key regions that you look for. Somewhere about 1700, something close to 1000. And then the alcohol group somewhere close to the 3000 mark. So you look to the left, start off in the middle and to the end. All right. So this peak indicates that we have C double bond O. All right. Notice we do not have any at 1000. We don't have any coming down at 1000 or even 1200. That peak is absent. Since it is absent, it means that we don't have any C single bond O. This one is for something close to 1000. This is something close to 1600, 1700. Right? So this one is there, but this is not there. That should tell you that you have a carbonyl group. Right? The question, you are trying to identify three, figures 3, 4, and 5 belongs to 3-methyl butanol. They are trying to identify an alcohol, heptanone, a ketone, and methyl pentanoate, an ester. So you are trying to find which one is the alcohol, which one is the ketone, and which one is the ester. Now remember, ester has C single bond O. I said that clearly that peak is not there. So this cannot be an ester. There's no OH group, there's no C single bond O. That leaves you with a carbonyl group, whether aldehyde or ketone. And in this instance, they gave you the name of a ketone. So that tells you that it is a ketone. All right? So this chart is not very difficult to interpret. All right? It's just 3 specific groups you are looking for. The 3000 to see if you have any OH. Close to 2000, if you have a peak there, C double bond O is present. If you don't have any at 1000, there's no C single bond O. So for this graph, I know it is a ketone because OH absent, C single bond O absent. C double bond O is present. All right. So that is how I know that this one, it would be heptanone. Compound is no. All right. This one, no. Remember, if it was a carboxylic acid, the peak, it would be much wider. It would look something just like this in red. All right. So this is an OH peak, but just in a regular alcohol, not a carboxylic acid. If it was carboxylic acid, it would be a wide peak like this one here in red. All right. Because it is not wide, it's a regular alcohol. Next, you do not see any peak coming down close to the 2000 mark, right? Which means that the C double bond O is absent. And now you have one coming down for the C single bond O. Remember now, alcohol, if you look at the alcohol, right, the C, O, and H. You still have a carbon to single bond oxygen. So this one, we don't really need it because once you see this, you know it's the OH group for an alcohol. All right? But you still can mention it. So you have a peak here for C single bond O, and you have the OH for the alcohol. So this one would have been the alcohol. Right. Let's look at this one now. So clearly, there's no OH group. Because remember, this peak, it is too narrow. Too narrow to be the OH group. No OH group is there. All right. Now, look at this peak, E, double bond O. Look at the peak close to 1,000, C, single bond O. Which functional group is that? C, double bond O, single bond O. That's your ester. All right. So justification, the peak at, this would be, let me see, about 17. So this peak corresponds to C, double bond O. Oh, for justification, you're just telling the wave number and what it represents. So this is a ketone. Reason why it is a ketone, the peak here at, let me see, 2,1918. Right, so the peak at 1750, you have a peak at, or a band, if you want to say a band. So the band at 1750, it represents C double band. And you also have one at, sorry, also have a band at, okay, 10, 11, 12. You put the wave number and the functional group it represents. Right? So that is how we justify. So because we have these two bonds here, and this one up here, it is insignificant because every compound is going to have carbon to carbon bonds. So it's the specific functional groups that are important. All right.